Hello everyone, welcome to today's VisualCADCAM 2016 webinar. My name is Anita Anand. I am part of the sales team in MecSoft Corporation. Now VisualCADCAM is our flagship standalone CAD/CAM solution. It includes 4 modules that can be purchased and licensed separately. We have Visual Mill, Visual Turn, Visual Nest, and Visual Art. Visual Mill provides 2 through 5-axis machining functionality. It is ideal for mold, die and tool, woodworking, rapid prototyping, and general machining. Visual Turn is our module for programming 2-axis lathes. Visual Nest is used for parts nesting. It includes both rectangular and true shape nesting. Visual Art is used to convert your artwork into geometry suitable for machining. Our main focus today will be to introduce the VisualCADCAM suite of products. We will start with an overview of the functionality for the benefit of those of you who are new to VisualCADCAM. And second, highlight the new features of the version 2016 of our for our VisualCADCAM users. Now VisualCADCAM is on version 2016, which was released this past Monday. It is the 11th release of our flagship CAM solution, so a very mature product here. On our panel today we have Uday, our support manager, who will be your presenter, Joe Anand, our product manager, who will also answer your questions during or after the presentation. Now some quick tips before we get started. Feel free to type in your questions using your chat window anytime during the hour. Uday, Joe, or I will answer the questions during the session. We will also have a short Q&A towards the end. Now if you are unable to get your question, we will send you an email with a response right after. Now we do have a lot to share during this recording. If we run over, do bear with us. We're just trying to fit in as much as we can. We are recording this webinar and we will make it available via our website in a couple of days. You will receive an email as soon as it is uploaded. We're now ready to get this going. Take it away, Uday.
We will be going over all the different modules that are offered in VisualCADCAM with our flagship Mill 2 to 5-axis programming module, Turn, Art, Nest, and also we'll go over all of the new features that have been introduced in the module. Without any further delay, I'm going to go ahead and launch the application in here on my screen. So I have the VisualCADCAM application loaded. You can either launch the application by selecting the shortcut on your desktop or from the taskbar and load the application. VisualCADCAM 2016 runs inside the VisualCAD framework, and VisualCAD offers you a variety of different CAD modeling tools and also includes a wide range of file translators. So if you take a look at the ribbon bar right at the top of your screen, you have access to your Home tab where you can load files from different CAD systems in here. So if you go under the File menu and select the file types, you can see that VisualCAD offers translators to bring in your existing files from VisualCAD, the older Visual Mill files. We have support for loading 3ds files, Illustrator, AMF, DXF, DWG files, IGES, Lightwave files, OBJ, Parasolids, Point Clouds, Native Rhino files, SAT, SketchUp, SLC, STEP, STL, Universal 3D, and VRML file formats. So VisualCAD supports a wide range of file translators. Now I'm going to go over some of the very nice modeling tools, 2D modeling tools that are offered in VisualCAD, and these can be found under the Curve Modeling tab. You could also work in multiple viewports as you create your drawings, or you can just maximize it to just stay and work in one viewport. So let's take a look at some of the CAD modeling tools here. All of your 2D curve modeling tools can be found under the Curve Modeling tab, and I'm going to model something real quick in here using some of the tools and show you the power of these tools that you can use for creating your 2D drawings and then extrude them into a 3D model. So let me go ahead and first create a rectangle. I'm going to draw a rectangle with rounded corners in here, so I can either pick 2 corners or enter in the coordinates right up in the command window, and I can also specify the radius for the corners. I'm also going to go ahead and throw in a rectangle in here, and you can see that as I'm trying to create the rectangle, the Visual Aid tool gives you help to basically model these drawings, and you can basically use these help to snap to the appropriate locations based on the object steps that you have turned on. So I'm going to go ahead and add in a few geometries in here, and what I'm going to do also is show you how we can edit these geometries. So you can go up to the object properties in here, and then basically select the geometry that you'd like to edit, and then enable the edit mode in here, and you can make changes. I can drag the node in here, or I could even select the circle in here and go back and change my radius. And if you need to make any changes, you want to drag your geometry in here, select the object, use the manipulator, and you can basically use the controls. So VisualCAD offers you a very nice set of tools to create your geometries. Now I'm going to use the powerful trim command in here, and enabling what is called the automatic command recall. And let me go ahead and trim some of these geometries out in here. So you can see that the trim command remains active as I'm trimming out these geometries. Now next, I'm going to cancel out of this command, and let's go ahead and merge all of these. I'm going to use the merge command, and then select the geometries, right-click or press enter when done. Now it's merged to a closed curve. And if I would like to go ahead and fillet these corners rather than having to fillet each of them individually, I'm just going to use the auto fillet command, specify a radius, and then I'll pick the geometry to fillet, and right-click and enter. You can see that the corners are now being filleted. I'm also going to go ahead and put some holes in here, and with the help of the visual aids enabled, you'll notice that it automatically gives me indicators to automatically snap to specific areas, and I can specify the diameter for these holes. With the continuous command recall turned on, the command automatically stays active in here, and I can keep creating geometries as in wherever I need them to be. So basically, I'm modeling these holes in here, adding some holes to the part, and if I also would like to put a pocket in here, I'm going to pick a pocket right there. I'll place a pocket right into the part. Now once I have this part modeled, it's ready for machining. Now if you want to turn them into a 3D model, I can use the extrusion commands either that are available under surface modeling, solid modeling, or under the mesh modeling tools. You can use the extrude command, select the geometries to extrude, and you can specify an extrusion distance, and if you can choose which direction you would like to extrude, and you specify height for it, and there's your extrusion. So that's how we can easily model 2D geometries and turn them into 3D, and these are now ready for your CNC machining process. So this basically gives you a quick overview of some of the very nice CAD modeling tools that are offered in VisualCAD. Now the next thing I want to point out is we have a new translator which is works as a plugin inside of VisualCAD, which can directly import files from Onshape, which is a parametric CAD modeling system. It's a cloud-based CAD system, and you can directly import your CAD files into VisualCADCAM 2016. So I've signed into Onshape using the Onshape document manager, so you can sign in, and then you can access all of your parts that you modeled in your Onshape account. You can select the part and then pick load, and this will automatically load the part into your VisualCADCAM workspace. So as you notice here, I got the part that was modeled in Onshape loaded directly into VisualCADCAM with just one click of a button. Now I got this part loaded in here. I'm now ready to program some toolpaths with it. So you can view the part in multiple viewports. You can switch to multi-view layout and program it. Now I'm going to go over milling the different CAM modules in here. So I'm going to click the Visual CAM menu. And first, I'll go through our free mill module, which is a free 3-axis milling solution. So I'm going to, before I select the free mill module, I just kind of prep the part. I want to add a little base to this. So I go up to the solid modeling, and I can say I want to create a box in here. And I'll just throw in a box at the floor of the part, and I'll put in a height, give it a thickness of 1/4 inch. There it is. So let's go ahead and load the free mill wizard. So click on Visual CAM and select free mill. And now in this wizard, you can basically establish your cutting directions. I would like to have my z-axis normal to the base of the plate. I'll set my extents of the stock. I'm going to offset the stock in the Z, define my work 0, put it to the stock higher Z in the southwest corner, specify my cutting tool. So I'm going to use a ball mill for generating a toolpath in here, and set my cutting feeds and speeds. I can specify all the parameters, but the spindle speed, cut feed rate, engage and retract feed rates. And then I go to my create machining operations, specify the step over, and then pick generate. So the free mill allows you to create 3-axis finishing toolpath, like a parallel finishing toolpath, and there's your toolpath. You can also control the step over, and you can as well run the simulation as well. There's your part that's programmed and simulated in free mill, and you can also post-process this out to your machine from the available list of over 200 plus post-processors that are included with the product. Now selecting post will allow you to write the G code, and I'm going to specify a file name for it, and I hit post, and there's your posted outbound. So the free mill module allows you to import or model solid surface geometries, bring it into VisualCAD, and generate 3-axis toolpaths. Now let's focus our attention towards our flagship CAM module, which is going to be the Visual Mill product. So I'm going to turn the attention over to the Mill module in here. So selecting VisualCAM and Mill automatically displays your Mill interface. The Mill interface has 2 main browser windows. We have the machining browser, which has 2 main tabs, Program and Simulate tab. And then we got the Machining Objects browser, which allows you to manage tools, your machining regions, whole feature detection, and also knowledge bases. So we'll touch upon the features in the Machining Objects browser as we go along during this webinar today. Now first, we want to go ahead and take a look at the different types of methods that are offered in our Visual Mill module. So we have 2-axis methods, which offers a wide range of methods, starting with facing, pocketing, high-speed pocketing, profiling, V-carve, roughing, engraving, chamfering, hole pocketing, and thread filling. Visual Mill also offers a wide range of 3-axis toolpath methods with roughing, re-roughing, finishing, remachining, pencil tracing, advanced finishing, curve-based machining methods. Visual Mill also offers 4-axis, both indexed and continuous methods, and also offers 5-axis, indexed and continuous methods. The whole machining methods are also offered, starting with drilling, tapping, bore, and reverse bore, and also in 4-axis. And there are several miscellaneous methods, and we'll take a look at them as we go through this webinar. I would now like to go over an example of programming a part using 2-axis. So I'm going to go ahead and load this part into VisualCAD. So we got this part loaded in here, and without any further delays, I'm going to show you how best we can program this part. So folks, if you do have any questions during this presentation, please feel free to ask us your questions. You can post your questions in the chat window, and we'll do our best to get them answered for you. So I have this part loaded in here, as you can see. And the first step in programming this part is making sure that the part that you've imported is in the correct model units. And then you want to establish the orientation of the part. So once you've established that, you can go ahead and define your machining process. You can define the machine tool. You can set the number of axes to be 2, 3, 4, or 5 axes. So for 2 and 3 axes, we would pick 3 axes in here, and then we'll pick OK. In the next step, we would like to go ahead and select the post processor to be used to output the G code. As I pointed out earlier, our CAM module offers a variety of different posts. We have posts for over 200 plus different machine controllers, so which covers a wide range of CNC machines tools that are out there. For this particular part, I'm going to use Haas as the current post processor, and then specify the posted output file. This could be set to NC, or you could use whatever is the preferred extension that your controller expects. If the extension is not available in the list, you can pick Add New to add your extension in here. In the next step, I would like to go ahead and build my stock blank, so I can click on the stock menu, and we have different types of stock types that we can define. So I'm going to go with a box stock in here, and the system automatically computes the minimum stock extents based on the part that you've imported. And I'm going to go ahead and specify my stock thickness to be 2.5 inches. And let's go ahead and pick OK. And you'll now notice that the stock is now defined and appears under the machining job. You can click on Show Stock Visibility, and the stock appears right on top of the part in your viewport. You can turn off the display of the grid if you prefer, and there it is. There's your part and the stock. In the next step, I would like to align the stock to the part. So I'm going to pick Align and choose Align Stock. And I'm going to set the alignment of the stock to the bottom in the Z. So the stock is flush to the, so I could face the material off from the top. And then I'm going to have it aligned to the center in X and Y. So once you have the stock and the part aligned, in the next step, we could establish the origin of your workpiece. So you can use Set World CS, and you can choose where you would like to establish the origin. So I typically like to prefer setting it to the top, the highest face in the Z, which is the highest Z, and then pick the southwest corner, which is over here on the left corner. When you pick OK, your workpiece origin or your work zero is set to the top face and the southwest corner. So when you switch over to the Simulate tab, you'll notice that your program zero or the work zero is set to the top face of the stock and the southwest corner. In the next step, you're now ready to program some toolpaths in here. So I'm going to go to selecting the machining methods. Now before I pick the machining methods, I can also select the material type I would like to use for programming this part, and I can choose them from the available materials in the list. And for this particular part, I'm going to pick aluminum 6061, and I'll pick OK, and you can click on the material texture visibility in here, and it automatically applies a texture to your stock blank. Next, if you haven't already defined your tools, you can go ahead and create your tools, or you can even load your tools from your tool library. Visual Mill offers a wide range of tools, starting with ball and mills, flatten mills, corner radius, V-mills for engraving, chamfering, you have taper tools, thread milling, face mill cutters, dovetail, fillet mill or corner rounding tools. You got lollipop cutters, form tools, or user-defined tools, and of course you have the drill, center drill, reamer, tap, bore, and reverse bore. You can have tools defined under each of these tool types, and also assign your properties for the tool. And as you go over to the Feeds and Speeds tab, you can also have Visual Mill help you compute recommended feeds and speeds based on the parameters, the stock material, the tool material, the tool diameter, and other properties. So once you establish these, you can save these tools to a library and load these tools on all the parts that you'd like to program. Now we got the tools loaded from a library in here, so now I'm going to go ahead and program some of the two-axis methods. We'll start with two-axis and facing. So we'll select the facing operation, and then we'll pick the features for facing. So I can choose select drive containment regions or select curve edge regions in here, and I'm going to go pick the edges on this part and select that as my drive geometry. In the next step, I'm going to specify a tool for it. So I'll grab the face mill, set the feeds and speeds by going to the Feeds and Speeds tab. I'm going to use the load from tool. In the next step, I'm going to establish my clearance to a safe Z height. It's set to automatic, so automatically it'll figure out the safe height for all your transfer motions and non-cutting motions. In the roughing tab, I can specify the parameters for the facing operation, specify the step distances in here, and the cut levels. You can specify the total cut depth. So the geometry, what I selected, I can say pick top and specify where to begin the cuts from. I can snap to the origin right there, and then I can specify my total depth by just snapping to 2 points. And there's my total depth of the 1/4 inch. I can do it in one or multiple passes, specify entry and exit parameters in here, and then I would go click Generate to have it compute the toolpath. So there's your facing toolpath right there. You can switch over to the Simulate tab. You select the operation in here, and you can hit the play button to run the verification. You can also toggle the display of the holder, and you can turn off the display of the texture and the toolpath visibility as you're running the simulations here. There it is. Quite simple. Now the next step, I would like to program these pockets in here. So before I program the pockets, I'm going to go ahead and create some machining regions from this model. So I would go over to the Regions tab, and I'm going to go into the Region Filter, and I'm going to choose Ignore the Inside Innermost Areas, and define a flat area region by picking this face. So you'll now notice that VisualCAM automatically creates a region for the pocket. I'm going to repeat the same step by flipping the region selections in here, and I'm going to create a region to basically pick the flat area again in here, so I can create a region for this pocket in here, right there. Okay, so now I would like to program this pocket in here. So I'm going to go over to two-axis milling, select pocketing, and for the machining regions, rather than selecting the face edges having to go through the process of picking each of those face edges, since I have a predefined region in here, I'm going to use select predefine. I'm going to pick the first flat area region right there, which basically is for the first step on the pocket in here. I'll pick that as my machining region. I go to my tool, specify a tool, set the feeds and speeds, define the clearance. The workflow is very similar to how we program the facing operation. Now we'll specify the cutting parameters. You can specify your tolerances, the stock allowance, stock to leave. You want to leave any side stock or wall stock. You could choose from one of these available cut patterns, specify a cut direction, set your step over control in here. You can also enable corner cleanups. You can add cleanup passes. Go over the cut levels where you can specify the location of geometry, and you can also pick the cut depth directly from the part. And there it is. You can also specify your entry and exit parameters for the pocket operation, and then click Generate, and there's your pocket toolpath that's being programmed right in here. So as you see, your pocketing toolpath has been programmed. You can click on Display the toolpath to view the pocketing toolpath, and then go over to the Simulate tab, hit the play button to run the simulation. You can also hit Simulate to end to run through it. Now we'll repeat the same pocket operation for the pocket with the island in here. So I'm going to make a copy of this operation, right-click, copy, and paste. And now I'm going to edit the operation in here and remove the current selection. And I'll pick the inside edge, inner edge of the pocket as one of my regions. And since I also have an island in here, I'm going to use the select flat area regions to go pick this island top face. So we now have two regions selected for the pocket. We'll use the same tool, the same parameters of feeds and speeds and clearance, and we'll use the cutting conditions where we want to leave some side stock along the wall. So I'm going to leave 25,000 stock, and we'll specify the depth in here. So I'm going to pick the total cut depth, just pick 2 points, one on the top edge, one near the floor of the part. So the total depth is 1 3/4 of an inch, and now I would like to basically step it in 1/4 inch increments. And I'll pick Generate. Now you'll notice that it automatically identified the topology of the part based on the drive curves that you selected. And since you have an island in here, selecting clear flats, clear island tops will automatically add an additional pass to clean up the top face of the island. So Visual Mill will automatically honor the Z height of the drive geometries that you selected, and with the clear island top selected, it automatically also finishes the island tops. And there's your simulation for the deeper pocket. And you could always pause and then skip the simulation by selecting Simulate to End. There it is. Now finally, I'm going to go ahead and program a profile operation to finish this up. So we'll go to 2-axis and select Profiling, and we'll now pick Select Flat Areas. I'm just going to pick the floor of this part. I have the part selected. We'll grab a 2.5 inch end mill, the same set of parameters for feeds and speeds and clearance. Under the cutting parameters, I'm going to choose Determine using 3D model, so the system will automatically determine which side to place the cutter. Specify my cutting conditions, entry and exit, and then select Generate to create a toolpath. And there it is. So this basically gives you an overview of the 2.5-axis methods that are offered in Visual Mill's module from standard through Pro and Premium configurations. Now let's take a look at the high-speed pocketing toolpath that's offered in Visual Mill. So I'm going to go ahead and open up one of these files. Now before I do that, I just want to quickly show you, once you have these toolpaths programmed, you could take a look at the information, which tells you how long it's going to take to program each of these parts. You can then post-process these out to your machine by right-clicking on the operation and then selecting Post. Specify your file name, destination folder, and then select Post. And there's your posted output file. You can also generate a shop documentation where you can basically create a setup information sheet. This will allow you to basically have the operator in the shop floor prepare the necessary tools, prepare the stock blank, the workpiece for machining the part, and the shop documentation can then be handed out to the machinist in the shop floor. So there is your shop documentation for the part you just programmed. Now let's go ahead and focus our attention to the high-speed machining toolpaths. Okay, here we go. So here I have a part which has several pockets on it, and I would like to showcase one of the very nice toolpath methods that's high-speed pocketing, which is offered in all of our configurations. So the workflow is very similar. Go ahead and select your machining features. In this particular case, I'm selecting the floor of these pockets. You specify a tool for it, specify feet and speeds and currents. Under high-speed cutting parameters, you can specify your tolerances, stock elements, and you can choose your cutting pattern, whether you want to do cut direction, climb, or conventional, and you specify your depths and then click generate. Now, high-speed pocketing is a very nice toolpath method which basically uses a constant cutter engagement, starts it with a spiral toolpath and creates a toolpath with a constant cutter engagement, so it basically has tangential arcs. This would help you in prolonging tool life and reducing tool wear. So this is a great method for those of you who are looking for some high-speed milling methods. And this is offered in all the configurations of our mill module. Now, the next thing I would like to focus on is one of the very nice features that's offered in Visual Mill is hole feature detection. Before I turn the attention into 3-axis milling, I would like to go over the hole feature detection methods that are offered in our VisualCAD mill module. Now, this part, the one I have loaded here, has several hole features on it, and I'm going to turn the attention over here to the Features tab in the Machining Objects browser. So I'm going to go ahead and have the system automatically identify all of the hole features on this part. So I'm going to use this feature called Create Hole Features. I'll pick this floor of the part, right-click on it, and you'll notice that it automatically identifies 6 features on the part. So there's one hole feature, and each of them has 6 instances. So all the features have been identified on the part. Now, you can easily program these features by clicking on Create Hole Feature Machining Operation, and you can notice that the system automatically displays the cross-section of the hole that needs to be programmed, and from the available operation types in here, you can choose the type of operations to be programmed. So typically, you'd want to do a spot drill operation, so I could start out with a center drill, and then I would want to do a deep drill operation, and maybe a hole profiling operation. So I'm going to drag and drop these operations under desired operations. I can also specify the depths for each of these. I can either enter them in or use the spinner controls in here to specify the depths for each of these operations. And once you have the operations defined, you click on Create Hole Feature Mop Set, and you'll now notice that these operations are they appear under your machining job. Now, if you'd like to change or swap out the tools in here, you can basically go ahead and drag and drop the tools. So for example, for the center drill, I would like to use a 1/4" drill bit. I'm going to use the same 1/4" drill bit for the deep drill, so I'm just dragging and dropping the operation on top of it. And I'm going to use a 1/4" flat mill for the hole profiling. Right-click and then regenerate will compute the toolpaths. Now I'm going to go ahead and save these operations, the hole feature operations I programmed, over to a knowledge base, so I can reapply the same hole feature operations on a part that has exactly the same hole features on a similar part. So what I'm going to do here is now go ahead and load in another part which basically has an exact match for the hole feature. So you can notice that I have another part has identical hole features. So first I'm going to go ahead and identify the hole features from the part by selecting the face on the part. The hole features have been identified, and you'll now notice that there's a feature called Select Matching Knowledge Base and Create Hole Features. So in this process, Visual Mill will automatically go look through your knowledge base of hole features, and if it finds an exact match, it'll automatically go ahead and generate your toolpaths. This is a very nice productivity feature, so you don't have to go through the process of reprogramming the same operations on different parts when it finds an exact match for the same hole feature. So you can build your knowledge base library of, for different hole features, and the system will automatically go find those for you when you do a select matching knowledge base and create a hole feature. The next thing I would like to do is focus our attention towards our 3-axis milling module and go through some of the very powerful 3-axis methods that are offered in Visual Mill. So I'm going to go ahead and bring in a part that has several features, which has sculpted surfaces, drafts on the part, fillets on the part. So parts like these are ideal for 3-axis programming. So the typical workflow in here is to define your stock geometry in here. So you can specify the stock dimensions. I'm going to go with the stock that's 3 3/4 inch. Establish the origin. So in this particular process, I'm going to set the origin to the lowest Z in the southwest corner. and then I'm ready to program some toolpaths. So the typical workflow is, first you want to rough it out with a large cutter, so we'll go to 3-axis and select horizontal roughing. In 3-axis milling, the containment regions are primarily used to restrict or contain toolpaths to specific areas. So in this particular case, since I would like to rough it out from the entire stock plan and bring it as close as possible to the finished shape of the part, I'm going to skip the selection of containment regions and go specify a tool. So I'll use a 1/2 inch end mill, set the feeds and speeds and parents, very similar to how we establish the feeds and speeds and parents in 2.5-axis operations. We'll specify our cutting parameters. You can specify the cut parameters. You can set your step over, your step down controls under the cut levels tab. You can also specify any additional parameters, like if you do not want to cut below a certain depth, you can specify under cut level containments, and then selecting generate will compute the toolpath. So the system automatically analyzes your part, the stock that you define, and creates your roughing toolpath. I'm going to hit simulate to run through the simulation. VisualMill also offers a variety of other toolpath methods in here, so I'm going to quickly go over some of the other methods. So I currently have a part that has several different methods programmed in here, and I'm going to go ahead and load in one of those parts, which includes some of the other methods. As you can notice here, we have a roughing toolpath followed with a finishing toolpath on it. So I'm going to go through the process of running through the roughing toolpath simulation, and there's your finishing toolpath in here as well. So there's a wide range of toolpath methods that are offered in VisualMill, starting with roughing, finishing. You also have horizontal finishing, which is finishing in levels, radial machining, 3D offset pocketing, pencil tracing, and remachining. So you can take a look at all of these different methods by also downloading a demo or evaluation copy of the product and play with each of these methods. Since we are pressed for time a little bit, I'm going to quickly run through some of our methods in 4 and 5-axis before we turn our attention to some new features in the product. VisualMill's Expert, Pro, and Premium configurations offers 4-axis indexed and continuous methods. With the 4-axis index methods, you would be able to create what is called rotate table setups, which will allow you to index your rotate table to any orientation by specifying a table rotation angle. And you can program 2 and 3-axis operations. So in this particular part, we have established the machine to be a 4-axis and defined the rotational axis to be along the x-axis, and programmed roughing toolpaths using indexed approach. So there's your roughing toolpath and simulation. So we're roughing it out from one of the orientations, and then creating a rotate table operation to rotate or turn the table over by 180 degrees, and then program the same roughing operation from the bottom side. So basically the part will be rotated over on your CNC machine tool. And then you can program a continuous 4-axis machining operation, or you can do a combination of indexed or continuous machining operation to finish the part. So there's the simulation of the 4-axis continuous methods. Now, other types of 4-axis methods, continuous methods, can be found under the 4-axis menu under the Program tab. So this basically gives you a quick overview of the 4-axis methods. The next thing I would like to demonstrate is 5-axis methods that are offered in VisualMill. So I'm going to go through the 5-axis simultaneous methods, which are offered in our premium configuration of the product. And the workflow is very similar, so you can bring in a solid surface geometry. You can define your toolpaths. You establish the machine tool to be a 5-axis. You can specify your machine configuration, and you can specify the primary and the secondary axis right up in here. So once you define the machine tool, you can program your toolpaths, and VisualMill offers a wide range of 5-axis methods: the curve machining, flow curve, between curve, dry surface, surface marble machining. And then you can run your simulation in here for each of these 5-axis methods. And there's a glimpse of your 5-axis swarf machining toolpath in VisualMill. The next thing I would like to do is turn our attention over to our turn module, which basically offers 2-axis turn programming solutions. And I'm going to go over and switch the interface to the turn module in here. Folks, if you do have any questions, feel free to post those questions on our chat window and we'll try to get them answered. So there it is. I now have a part loaded in here, and this part is ideal for programming on your CNC lathes. So to switch from the mill to the turn module, you can click on VisualCAM and then select turn, or click on this button on the mill module to toggle from mill to turn, and this automatically displays your turn interface. The turn module offers two-axis turning solutions starting with roughing, finishing, groove finishing, follow curve, threading, and parting off. The workflow is you define your part, so you can select the solid surface or curved geometries to establish your part. And once you establish the part, you can basically build your stock, define your stock geometry, and then you can specify your work serial, which allows you to establish your work origin, and then program turn roughing and turn finishing toolpaths. And I can go to the simulate window, select the play button to run the simulation for your turning process. And there it is. So there's your turn roughing up, finishing, grooving, threading, and ID operations. You can also switch the simulation to a 3/4 view to run through the simulation. The next thing I would like to do is turn the attention over to our art module. So quickly go through some of the features in the art module, and then we'll take a look at the new features in our 2016 version of VisualCADCAM. Now the art module in VisualCAM allows you to convert artwork into reliefs that are suitable for 3D machining. So to select the art module, select VisualCAM and art. This automatically displays the art browser. So if you have curved vector geometries, you can bring them in and create 3D reliefs, or you can even use the raster to vector feature to convert raster images into vector geometry. In this particular example, I have some curves on the model, and I'm going to show you how you can create some project relief operations. The first step is to define a project, which allows you to basically create like a canvas under which you can build your relief operations. So once you define your project in here, you can go ahead and create puff and swept volumes. In this particular example, I've created a couple of sweep operations, puff operation, and relief operation by specifying a texture to apply using a 3D relief operation. And there's your relief operations that are created. You can create sweep operations, puff operations, and relief operations. And once you have these operations created and the relief generated, you can export these into VisualCAD, and now these are ready for your CNC milling applications or any other downstream applications. So we are exporting the relief that's generated in Visual Art back into VisualCAD, which can then be programmed using our Visual Mill modules. You can generate 2- and 3-axis toolpaths from it. Now while I'm waiting for the export process to be completed, I'm going to go ahead and load in another session of VisualCADCAM, and we'll try to take a look at some of the new features that we would like to showcase in our 2016 version. Looks like the export just got done in here, so you can see that the relief is now exported as a mesh geometry. You could go into the mill module and you can generate toolpaths. So you can go into generate 3-axis toolpaths, or you can program a combination of 2- and 3-axis toolpath for the part that's appropriate for it. Next, I would like to turn my attention over to the new features in our mill module. Without any further delays, I'm going to go ahead and I'm going to bring in a model which basically will showcase a new method in 2-axis called 2-axis and roughing. So in this particular method, the system automatically treats the boundaries of the part that you select as the areas not to be cut, and it automatically takes into account the stock that you've defined to create a toolpath. So I'm going to go over to 2-axis and then pick roughing, and what I'm selecting here is the part that not to be cut. So basically I'm picking the boundary around this part in here, and the system automatically determines the stock, so it knows what the stock which you define, and the curved region what you selected is the boundary of the part, so it automatically figures out the toolpath. So rather than having to go through the process of creating facing, pocketing, or multiple different operations, the roughing operation automatically determines based off the part and the stock geometry and helps you in creating these toolpaths. So you can specify your parameters under the global parameters. You can specify your cut pattern, step over. You can also control the cut levels, and then pick generate, you'll now notice that it automatically determined the areas that needs to be cut. Now, if you also selected area inside this pocket, it will also automatically program the pocket toolpath in here. So let's go take a look at the simulation, and you'll notice that it automatically created a facing toolpath, the roughing operation. Had I also selected the feature on the inside pocket in here, you would have automatically programmed the pocket as well as the exterior geometry. So you can use the two-axis roughing operation to automatically program toolpaths on prismatic parts. So this is a great way to, reduce your programming time, improve the productivity. Two-axis and roughing operation. Now the next thing I would like to go over is there have been several improvements made to the high-speed pocketing operation, and also in the two-axis pocketing operation we've added the option to do loops. You can do corner cleanup loops in here. You can do inside loops and outside loops. You have the option to specify these in the corner cleanup options, and as you specify and program these toolpaths, you will notice that the loops are being generated. The high-speed cleanup loops have been added to the pocketing operations. So these are some of the new features, enhancements that have gone into the two-axis methods. Now I would also like to go over some of the enhancements in the three-axis methods that are offered in the 2016 version of our product. So I'm going to go back into this example which shows a sculpted 3D model, and I'm going to generate a three-axis parallel finishing toolpath on it. And in this parallel finishing operation, you have the option only to cut tops only, or you can do both tops and bottoms. So I'm going to show you the option to do tops only, and I'll specify a tool for it with a ball mill. And you'll notice that the system automatically computes the toolpath just for the top areas. Now if you go back in here and select do tops and sides, it'll automatically also do the sides on the part as well. The parallel finishing can do tops only or tops and sides. This is also one of the new features that has been added to the three-axis methods. The three-axis horizontal finishing method has also been enhanced, the optimized machining, to reduce the number of retracts, what you used to typically notice in the 2015 version. So here's an example of the horizontal finishing toolpath with optimized machining. You can see that there are several retracts in here. As you take a look at it in the 2016 version with the same optimized machining, the number of retracts have been drastically reduced. So this is a big improvement for horizontal finishing, and also saves you time. So the next thing I would like to go over in the 2016 version of the product is we have introduced what is called a knowledge base automation, and I would like to go over this feature in here in detail. And for this, I'm going to go ahead and load in an example in here. So I'm going to go ahead and bring in this part. The part here, what you see is basically just a 2D drawing, but to demonstrate the knowledge base feature, this is a great part to go over it. Now, I already have this part programmed, so I'm going to bring in my knowledge base of operations in here that were programmed from another part. So once I load the knowledge base in to the knowledge bases tab or the K-bases tab under the machining objects browser, I could go ahead and assign rules to each of these operations in the knowledge base. So I can expand the operation folder, and you'll notice that there's a new entry called selection rules. So you can double click on it and you can assign rules to it. Now before I assign rules to it, I want to let you know that in this particular part I have layers, and as you can see, the layers are named and been organized in here. So you can see that I got layers named called holes, pockets, drills, engraved, and cut out. So what I'm going to do is assign rules. The rules can be assigned in a couple of different ways. I can assign geometries, or I can also apply layer filters. Now for the engraving operation, I would like to automatically have it select all of the points and all geometries that are on layer engraved, and I'm going to pick OK to apply it. For the whole profiling operation, I would like to pick arcs and circles of a specific diameter range, and I'm going to choose a range from 0 to 1 inch in diameter. Now for the holes, larger holes, I'm going to apply a rule so I can specify have it to select arcs and circles of a range from 1 to 5 inch in diameter. And finally, for the outside profile operation, I'm going to assign a rule to automatically select all geometries on layer cutouts. And I'm going to pick OK here. So now you'll notice that for each of these operations, we have assigned rules to it. Now I'm going to go ahead and select this knowledge base and drag and drop it into the machining browser. You will now notice that as I select each of these operations, the corresponding machining features are automatically selected on it, as you notice it in here. So the engraving operation has automatically added the points and the geometries on layer engraved. The hole profiling operation has automatically selected all of the holes within the specified range, and the hole profile, the two-axis profiling operation has automatically selected the outside cutouts. Now when I right-click and regenerate, the toolpaths have been automatically computed for this. Now how can we apply this to other similar parts which have similar set of features? So I'm going to go ahead and save this out to a knowledge base, and I'm going to specify a folder where I'm going to save it in here. I'll just call it Part 101 with rules. And I'm going to save this knowledge base. Now this knowledge base is now saved with the rules, the selection rules for it. Now I'm going to bring in another part, and you'll notice that this part has similar set of features. There's much more larger set of features. Now in the previous versions you had to load the knowledge base and go manually pick those machining regions for each of those operations. Now with this 2016 version with the rules, you can actually go ahead and select this rules knowledge base with the rules that you just created in here, and as the knowledge base is loaded, you'll notice that it automatically has also added the geometries automatically into it based on the rules that you specified. So now all you got to do is right click and regenerate, and your part is completely programmed. So it was just a three-step process. Step 1 was loading the part, step 2 was loading your knowledge base with the rules, and step 3 was just to right click and regenerate it. So within just a few button clicks, you're able to fully, completely program this part. So I'm going to go back and repeat this again for one of the parts. So for those of you who wanted to get more familiarized with this feature, so you bring in your part. That was step 1. Step number 2, load your knowledge base which you just created with the rules. Step 3, right click, regenerate. So your toolpaths are now being generated automatically with the rules that were specified in the knowledge base. So this is a very powerful feature that's being offered in all configurations of VisualCAM 2016, and it's a very nice productivity enhancement that will help you program parts much faster, and you can, improve the efficiency. Now the next thing I would like to point out in here in our 2016 version is we've introduced a new feature called Explode Cabinet Design. For those of you who are cabinet makers, this is a great tool that's built into VisualCAM 2016. So for this, I'm going to go ahead and bring in a new part. So let me go ahead and just bring in a new session of Visual Mill. I'm going to go up and load the mill module in here. And for this particular part demonstration, I'm going to go ahead and bring in a model. I'll bring in a file from a SketchUp model in here, which is basically a cabinet design. And you'll notice that we now have a cabinet model that's imported into VisualCAD. So what I'm going to go over here is show how we can flatten out these parts so that can be used for then, you can nest them out and then produce these parts on your sheet for your CNC routing or CNC milling applications. So we got a part, that was a cabinet model that was loaded in here, and there are several flat panels on it as you see it right there. So we would like to flatten them out. So we want to go into the feature under Utilities and click on Explode Cabinet Design. So when I click Explode Cabinet Design, it automatically brings up this dialog interface where you can choose to explode all visible geometries, or you can do explode only selected geometries where you can graphically pick the geometries, or you can only explode geometries that are on specific layers. This particular example, I'm going to choose explode all visible geometries. And once you select this, you can also specify how you'd like to have these components placed. You can either have them spaced along a single row, single column, or you can have it array with fixed distance along X or Y. You can also specify the spacing between each component. And you can choose to output both components, both 3D geometries and 2D curves, or you can only choose to create only 2D curves or just the 3D geometries. And you can also choose whether you want to explode them into a new layer or you can want to retain them in the current layer. So in this particular example, I want to create them into a new layer, and I would like to have them along this single row, and I want to specify a spacing of 0.3 inches between each component. So when I click OK here, you will notice that it automatically decomposes this, and all flat panels have been decomposed and exploded. So you can see that the panels are now laid out along X axis, as you can see along X axis right there. Now, if you go into your layer manager, you'll notice that there's a new layer in here, and if you'd like to hide the cabinet model, the cabinet model hasn't been removed or deleted, they're automatically hidden, as you noticed the option in the cabinet decomposition dialog wizard. So now we have this model in here, which all the flat panels, and you can see it has both the mesh geometry, the curve geometry, and also the curves for each of these. Now, you may have to do a couple of steps in here to clean up, to create, to basically just retain the curve geometries in here so you can nest them into a sheet. So what I've done is I've already just, cleaned up the model, so I only have the curves. There's a couple of steps you go through basically to eliminate the geometry that you don't need, and what I've ended up with is just basically these curves from the explode cabinet design process. So what I got in here is just the curves that we exploded from the cabinet design process. In the next step, I would like to nest these parts into a sheet so I can basically produce them on my CNC mill or CNC router. So I'm going to go into the VisualCAM's nesting module. So click on VisualCAM and Nest, and this displays the nesting browser, and it's a wizard browser, as you can see. There's two types of nesting available, true shape and rectangular. Now for this particular part, rectangular nesting, it would be ideal. So I'm going to pick rectangular nesting, and in the next step I'm going to use select sheets to nest into the part. So I can create my sheet in here. So I'm going to draw a rectangle. I can specify the size of my rectangle. So I'm going to create a rectangle that's going to be 96 by 48. So I have a rectangular sheet drawn in here, and I'm going to stage the sheet and the part away from each other. So basically the parts would get nested into the sheet. So I'm going to use select curves and select the sheet I just created in here. And you can also specify the count or the quantity of the sheet that you have available. In the next, I'm going to use select the parts to be nested, and I can go ahead and click on select curves, and I'm going to drag a window to select all of these parts in here, and right click or press enter when done. You'll now notice that the nesting module automatically knows the topology of each of these parts, and it groups all the holes that belong to the part into the same part right there. So you can see that a couple of parts have holes on it, so they're automatically grouped as part and holes, as you notice it right in here. So once you have the parts selected, you can specify the count, the quantity. In this particular case, since I just need one copy of each, I'm going to leave the count as 1. You can also specify the orientation and grain direction if needed. In the next step, you can choose the nesting parameters, and now you can specify your distance between part to part, and specify the distance from the part to sheet, and you can specify, use these additional options if you want to tag the nested curves. These are some of the new features that you added in 2016. You'll notice that the nested sheets can be either laid out along X, along Y, or you can have them stacked, and you can also specify the spacing between each sheet. And when you hit estimate number of sheets, the system will let us know that to be able to nest all of these parts into a sheet, we need a total of 2 sheets. So I can go back into select sheets to nest part and change my sheet count to 2. And I'm going to go back in here and execute the nest. Click on preview nest. You'll now notice that the parts have been nested into the sheets, and there's your first sheet and the second sheet. Since we chose to nest them along X, the sheets are basically being right next to each other, and you have the option either to create a separate layer for each nested sheet, or you can just leave them as, on the same layer. So I would like to have them on separate layers in here. So I'm going to click on Commit Nest, and you'll now notice that your parts have been nested into 2 sheets, and there's the result of your nesting. And once you have these sheets nested, you can go ahead and switch over to the mill module and program your toolpaths. Now, if you organize the holes into a layer called holes, and then the dados into a layer named dados, you can tie in the knowledge base automation that we just talked about earlier into the nesting process. So basically, within a few clicks, you are able to produce your toolpaths and have the parts post-processed and sent out to your CNC equipment. So with this, I would like to hand this back to my manager, Anita, who will be able to give you more information about our VisualCADCAM 2016 product.
Thank you, Uday. That was a lot covered today. We have plenty more, but unfortunately, this is the time we have. Any question, folks? Anything we can answer for you? We have a few minutes that we could spend with talking about any questions that would help you. Well, there's one that you could perhaps answer, Uday. Using the cabinet feature, will it handle a SOLIDWORKS assembly served as an IGES?
That's a great question. Yeah, you could import any solid surface geometry into VisualCAD, and then you should be able to use a cabinet explode decomposition feature to explode them into flat panels. The SketchUp file was just one of the cabinet files I use as an example, but you should be able to import any solid surface geometry to be able to explode it.
Okay, thank you. Any other questions, folks? Is it possible to make changes in the post processor for Visual Mill, Uday? That's one you can take on.
Absolutely. The post processors can be edited and customized. So if you go over to the post processor options and you select edit, you can go into the post generator and you can customize and edit your post processors. And the post generator is built into the product, so if you need help in editing it, you can always reach us out at support at MecSoft.
Okay. There was another question about a fully functional version of this for SolidWorks as a plugin. Yes, we do have VisualCAM as a plugin for SolidWorks. The mill and the turn modules are integrated with SolidWorks, and the release for the 2016 version will be towards the end of this month. So you will see all of this. We do not have a nest and an art module embedded in SolidWorks, but we do have the mill and the turn. Do you have a plugin for space claim? At this point, we only have an export plugin, and the 2016 has not been released yet. It would be shortly.
I'd like to jump in. Anita, I'd like to jump in there. This is Joe regarding the plugin for space claim. We don't have any plans for that. Our next big foray would be into cloud. And that's our focus for the coming year. So we will be adding some sort of cloud functionality. We've already started our partnership with Onshape to offer our product in their app store, and we will be taking that along to a full-blown cloud solution, hopefully sometime in this year, if not early next year. So that's our future. Thank you.
Thanks, Joe. Thanks for correcting me on that one. There was another question. I get a lot of questions about the pricing. Pricing is available on our website, and upgrade pricing as well can be sent out right after the webinar. I can provide the North America pricing. And for our international viewers, do connect with your reseller in your area, and they should be able to give you the exact upgrade and new product pricing. Now, there was another question about a plugin for Geomagic Design. That product has been discontinued, and we will not be releasing a plugin for the 2016 version. And I can offer details offline if that's something you are interested in. Now, the one thing that I think we should bring up this time around is our advanced simulation feature has been added to all configurations of the product, and I'd like to stress on that because that's something all our customers were really interested in. So it's something we did add, we did listen to you, and added it in all the configurations. Well, I think we are just about out of time here. I'd like to thank Uday, our presenter, and Joe, who's been in the background answering your questions for us. And thank you to our audience, our great audience. We got a lot of questions this time. Thank you for joining us and attending our webinar this morning. The webinar has been recorded. You will receive an email as soon as it is uploaded on our website for viewing. As usual, we are available for questions during the week. Call us, email us, Skype us, chat with us. Do follow us on Twitter and Facebook. Keep in touch. And until next time, folks, take care.